this video, I'm going to walk you through a project I built called the AI-powered Sales Anomaly Detector, a full-stack data science application that automatically finds unusual patterns in sales data and use artificial intelligence to explain what's going on. This is built using Python, Fast API, Streamlit, and Plotly, and it combines traditional statistics with a large language model to give you for the detection and the explanation in any anomaly it finds. Let's dive in. So first, let's upload our data and click here. So imagine you are a business analyst and every day you are looking at thousands of rows of sales data. How do you usually know if something unusual happens? Like, did revenue spike because of a successful campaign or did it crash because of system failure? So that's exactly what this tool solves. So you simply upload a CSV, like your sales CSV file, and within seconds the app will give you like one automatic scan your revenue data using a statistical method called rolling z-score analysis. And two is like plot every anomaly on an interactive chart, so you can see exactly when and where things went wrong. And third, use an AI model to generate a plain English explanation of why the anomaly likely happened and what your team should do about it. So, no manual analysis, no complex dashboard, just upload and get your answers. Let me quickly show you how this architected because the design is actually quite clean. So, first, the project follows a decoupled architecture. There are two separate services running. First, an API, fast API backend here in the main.python. This is the brain. It handles all the heavy lifting, reading your CSV, running the statistical analysis, generating the charts, and rolling the AI model. Second, a Streamlit frontend inside the app folder. We have UI.python. This is purely the visual layer. It does not do any analysis itself. It just sends you files to the backend API and displays whatever comes back. And in analysis of Python, here the code logic lives. This is where the 30-day rolling z-score algorithm runs and where the LLM explanation is generated. And when coming to the plotting.python, it builds the plotly charts. The whole thing is containerized with the help of a Docker, and so anyone can run it with a single command. The statistical method used here is called rolling z-score. Here, how it works in a nutshell. So for every single day in your data, the algorithm looks at the previous 30 days and calculates the average revenue and the standard deviation. And for and then it calculates the z-score, which tells us how far today's revenue is from what's normal for that time period. Any day which where the z-score is greater than 2.5, like meaning it's more than like 2.5 standard deviation away from the rolling average gets flagged as an anomaly. This is powerful because it adapts to seasonal trends. So it won't flag high Christmas sales as anomaly just because they are high. It compares them to the recent history, not the whole year. So let's see it in action. So I have a sample sales data here with like 360 days of revenue of for the year 2024. So I just browse it and I upload the CSV and click the button. There it is. Look at the chart. The blue lines is our daily revenue and across the entire. Are those the red dots? Those are anomalies. So we can just hover and check the date and the revenue with respect to that. And in March, we could find one anomaly right here where the Z score is almost like 5.21 in general. And then hovering about this, and at particular point, we can see that uh, in June, the Z score has gone to negative 4.07. There is a lot of deviations. So the AI has written a plain English analysis, like a statistical significant revenue spike was detected on 2024 March 15. Actual revenue of $48,500 deviated 313%, 0.7% from 30-day rolling average of $11,723.98, well beyond the plus or minus 2.5 anomaly threshold. Common possible cause include a successful campaign, bulk order from major clients, or viral marketing event. Recommended actions: cross-check with the CRM and order management system for that date. Consult the marketing and operational teams for any known events, and on to the following 7 days of continuation or correction. So this is incredible use for business teams who don't have a data science background. So they get the finding and the recommendation instantly. Because the backend is a proper REST API built with fast API, it also usable programmatically. Here is the auto-generated API documentation. So there's a health check and point, great for production deployments. To wrap up, this project demonstrates how you can like combine classical statistical with modern AI, to build a genuinely useful business intelligence tool. The full stack includes fast API for the backend API, Streamlit for front-end dashboard, Pandas and NumPy for the rolling Z-score analysis, Plotly for interactive visualization, and Anthropic Claude or Olama for AI explanation, and Docker for one command deployment. The project also has a full unit test suite, 29 tests covering the statistical logic, edge cases, and the AI prompting, and an evaluation script that verifies that the anomaly detection achieves a 100% match rate against known anomalies. If you found this useful, give it a thumbs up and drop a comment below. Thank you so much for watching.